Hello, good morning. We are moving on to lesson 5.5 today. We are almost at the end of chapter 5 actually. This was a pretty short chapter. We're talking about prime and composite numbers today. So go ahead and find your math journal. We're on page 305. You may need your multiplication chart and a pencil. Alright, so again we are on page 305. If you were at morning meeting this morning, you probably already have this page filled out because we did it together. But just a quick review, the difference between a prime number and a composite number. So a prime number is a whole number, which just means 1, 2, 3, 4, 5, 6, 7, just regular numbers, greater than 1, that has exactly two factors, 1 and itself. So that means that a prime number is a number that can only be made by multiplying the numbers 1 and itself. So for example, we already talked about this, but again, 13 is a prime number because the only factors it has are 1 and itself, which means 1 and 13. So 13 is a prime number. There's not another way to make the number 13 in multiplication except for 1 times 13. But 12, the opposite of this, is a composite number. It is a whole number greater than 1 that has more than 2 factors. So if you think about your factor rainbow again, for 12, I know that 1 times 12 is 12. I know that 2 times 6 is 12. I know that 3 times 4 is 12. Oops. So the factors of 12 are 1. I'm going to put them in order from least to greatest. 1, 2, 3, 4, 6, and 12. So because 12 has more than 2 factors, it is called a composite number. Okay, so keep those definitions in mind. If you need to come back to them, they're on page 305. But go ahead and flip the page to 306 now. Remember when I said to bookmark or like put a dog ear on page 286? It might help you on this question. Those are the divisibility rules. It says you can use divisibility rules to help tell whether a number is prime or composite. So instead of doing long division and seeing, for example, this one, 51, if 51 can be divided by 2, 3, 4, 5, 6, 7, 8, 9, and doing long division for each one, you could use your divisibility rules to quickly tell whether it's prime or composite. So it says if a number is divisible by any number other than 1 in itself, then the number is composite. So on this example, we're looking at the number 51. Is 51 prime or composite? So just off the top of my head, I can't think of any basic facts that equal 51. And so if you look on page 286, the divisibility rules though, this is a quick check. So start with 2. It says, is 51 divisible by 2? Remember that the rule for 2 says it has to be an even number. So this is not, it's an odd number. So no, it's not, because it's not even. Now try 3 though. Is 51 divisible by 3? Remember that, or look back on page 286, the rule for 3 is that if the sum of the digits, so if you add up 5 plus 1, can that number, 6, be divided by 3? Yes. So that means that 51 can be divisible by 3. And the reason for that again is because I added the digits and the sum of them. 6 can be divided by 3. So 51 is a composite number because I just figured out that it has multiple factors because it can be divided by 3. Okay, go on to the next part, share and show. Remember that another way to figure out different factors of a number is to use the grid and make a little model. So it says to use the grid model. Use the grid to model the factors of 18 and then tell whether 18 is prime or composite. So you're trying to figure out if 18 has more factors than just 1 and 18, 1 in itself. So think about if you're going to use the model, different ways to make 18, make a rectangle with 18 boxes in it. So the first one we always know is one row of 18, because 1 times 18 is 18. How else can you make 18 though? You could do 2 rows. I think that's not, but 2 rows of 9, because I know that 2 times 9 is 18. You could also do 3 rows of 6, because you know that 3 times 6 is 18. So that proves that this number is composite, because it has more factors than just 1 and in itself. So you could use the model, or the other way, remember, was you could make the factor rainbow if you're not into models. I know 1 and 18. I know 3 and 6. And I know 2 and 9. So you can list those. Again, when you do it online, it's probably going to ask you to do it from least to greatest. So that's another way that we know that the number is composite. So go ahead and try the next 1 through 5, and even you can go on to page 307 if you want. Just pause the video and check back in when you're done. But we're telling whether the number is prime or composite. So the question to ask yourself on all these, it says, does 11 have other factors besides 1 in itself? When we say itself, we mean 1 times 11. So does 11 have any other factors besides 1 times 11? Think of your basic facts. Can 11 be made any other way besides 1 times 11? No, it is prime. 73. This number is a little bit bigger, so you might not have all your facts memorized, so you could double check with your divisibility rules. For example, I know it can't be divided by 2, because it's not even. You could try 3 though. Remember the sum of the digits. If that can be divided by 3. That 7 plus 3 is 10. Can 10 be divided by 3? No. So it can't be divided by 3. I can't think of 4 times something equals 73. 5 wouldn't work because it doesn't end in a 0 or a 5. 6 does not work because it had to be divisible by 2 and 3. And 9 doesn't work because 10 can't be divided by 9. So this has to be prime. Number 469. I can't think of any basic facts, but again, if you try the 3 rule and you add the digits, 6 plus 9 equals 15. Can 15 be divided by 3? Yes. That means that 3 has to be a factor of 69. So right away, without even thinking about it even more, I know it has to be composite. What about 42? I know that 1 times 42 is 42, but can you think of any other factors? You might have thought of 6 times 7 is 42, which would make it composite, or another divisibility rule is, because it's an even number, that means it can also be divided by 2. The other way to do this, if you don't want to use the divisibility rules, is to just do long division and see if you can get you can divide by different numbers without a remainder. All right, go on to the next part. Try these on your own. Pause the video. Check back when you're done. Number 6, 18, is that prime or composite? We already did that one. Did that one on the last page. That's composite. Again, you guys should see how this will be a lot easier if you memorize your basic facts. You could look on your multiplication chart, I guess, but it would be faster if you memorized them. Number 7 is also composite because I know that 7 times 7 is 49. 29, I'm thinking it's prime because I don't know any basic facts that equal 29. I also know it can't be divided by 2 because it's even. And I know that if I add to the digits, 2 plus 9, you get 11. And that cannot be divided by 3 or 9. So 3 and 9 can't be factors. So I'm pretty sure this is prime. Number 9 is composite because 8 times 8 is 64. I hope you guys have tried these on your own because otherwise you're going to think I'm going really fast. But 33 is composite because I know that 11 times 3 is 33. 89, I don't know any basic facts, so try your divisibility rules. Go back to page 286 and use the rules to check. 89 is odd, so it can be divided by 2. I also know it can't be divided by 5 because it doesn't end in a 0 or a 5. So now go try the weird ones, the 3 and the 9. You add the digits up. If you do 8 plus 9, you get 17. Can 17 be divided by 3? No. That means that 3 is not a factor. Can it be divided by 9? No. That means that 9 is not a factor. And 6, it had to be divisible by 2 and 3, which it's not. So this number is prime. 52, even though I don't know any basic facts, it's an even number, which means it can be divided by 2. So that means it's composite. And then 76 is also even, so it can be divided by 2. So that means 2 must also be a factor. Okay, think about 14 and 15. Pause the video, try these on your own, see if you can figure these out. Number 14 says true or false, only odd numbers are prime numbers. Okay, so think about that. Are there any even numbers that are prime? This statement is false. Most of the time, even numbers are composite because they can be divided by 2. However, if you think about the number 2, which is even, 2 is prime because, uh-oh, pen, does my pen stop working in every video? Because, so 2 is prime because its factors are just 1 and 2. So since the factors are just 1 times itself, that makes the number prime. It doesn't have any other factors, and 2 is even. So this statement for 14 is false. Number 15 says a composite number cannot have 3 factors. So usually, like for example, factors for 6, numbers that make 6 are 1 and 6, 2 and 3. Usually composite numbers have more than, and they're asking about 3 factors, but can you think of any numbers that have just 3 factors? This statement is also false. If you think of numbers like 25, the factors of 25 are 1 times 25, but the other factors are 5 times 5. Since you multiply 5 times 5, you only have to list the 5 once, so this one does have 3 factors, so this is false. I can think of the example of 25. You could also think of 4, because the factors are 1 times 4, but then 2 times 2 is 4, so the third factor is just 2. Alright, we're going to go ahead and jump down to the bottom. We're going to skip number 16 for now. Look at 17 and 18 though. Number 17 says, name a 2-digit odd number that is prime. And then name a 2-digit odd number that is composite. So think of prime now. We only want numbers that have factors of 1 in itself. There are like tons of examples you could use. Look, think of 2-digit numbers. The first 2-digit number is 10. Is that prime? No, because it has more than 2 factors, because 2 times 5 is 10. What about 11? 11 is prime because its only factors are 1 and 11. 12 has lots of factors, but 13 only has factors of 1 and 13. 14 has more than 2 factors, 15 has more than 2 factors, 16 has more than 2 factors. 17 would work though. You could keep listing up and up and up. What about composite numbers? Name a 2-digit odd number that is composite. So think of 2-digit numbers that are odd. 10 is even, so that wouldn't work. But 11, is 11 composite? No, because it only has 2 factors. 12 is even. 13 we already said is prime. 14 is even. What about 15? 15 is an odd number, and 15 has more factors than just 1 times 15, because you can do 5 times, 5 times 3. So 15 would work. Go to the next 2-digit number, 16 is even. 17 is a prime number, we already said. 18 is even. 19 is prime because 1 times 19 is, they're the only factors. 20 is even. But the next number, 21, is an odd number, and it's composite because I know that it has factors 7 times 3 and 1 times 21. So again, you could keep finding more if you want, but those are a couple examples. And then number 18, choose the words that correctly complete the sentence. The number 9 is either prime or composite. So think of 9, think of some factors for 9. Automatically I know 1 and 9. If you can think of any more factors, that'll make it composite. I know 3 times 3 is 9. So because it has more than 2 factors, 9 is composite. And then it says because it has more than 2 factors. So again, knowing your basic math facts and looking back at your divisibility rules will really help you figure out if a number is prime or composite. If you are looking for kind of a cool activity, turn the page and try page 308. It's a really famous model or example of how to figure out numbers that are prime less than 100. It's called the Sieve of Eratosthenes, and it talks about this guy Eratosthenes is a Greek mathematician, and he created this very famous model that shows the numbers that are prime that are under 100. So that's kind of a fun activity if you're looking for something else to do today. Otherwise, please let me know if you guys have any questions, and I will talk to you later.